Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG. And this is our first video in a series of videos about probability and how probabilities are asked in the exam end of the year. I'm going to today specifically look at the probability type questions you can get from grade 8 to 11. So in other words, not looking at the fundamental counting principle, but looking at tree diagrams and maybe looking at some more other type of questions. Now, can unfortunately not do all the different examples you might get, but please tune in next time where we are going to do grade 12 fundamental counting principle videos. And then in the week following, I'm going to do a live streaming session where I promise to do at least one or two more grade 8 to 11 type questions. Let's start today by looking at a question that requires a tree diagram. So this first question asks, Kia and Ray are given one attempt at shooting at the target in a game of archery. If the probability that Kia will hit the target is 4/5, and the probability that Ray will hit the same target is 3/4, find the probability that the target will be missed by one of them. Now, as you see, this is a 6-mark question. In other words, not easy, but not that difficult. Now, why do I say this is a tree diagram sum? Because there are two events that happen directly after each other. Simultaneously doesn't really matter, but there are two events that's happening. First of all, I've got Kia. Now she has got two options, hit and miss. Then I've got Ray shooting and she can hit or miss. And there's my tree diagram. But now I must never forget to actually put in the probabilities. So first of all, that 4/5 for Kia means that her probability of hitting the target is 4/5, but the probability of missing is 1/5. Complement rule, complement rule, complement rule. Do not forget about the complement rule with these kind of events. Same I'm going to do with Ray. The probability of her hitting is 3/4 and missing will be 1/4. Let's just put that in for the bottom ones as well. What is the question now asking us? Find the probability of one of them missing. I've got therefore two options. I can either have Kia missing and then Ray hits the target, which is our green road that we're going to walk, or I could tell them, but Kia hits, but then Ray misses. That's going to be the yellow road we walk. Almost like the yellow brick road, but we don't have bricks here. So in the first one, if I look at the green road, I've got 1/5 as being the first probability. And then I walk to 3/4 because Kia misses and then Ray hits. That's the green road. Or then I go Kia hitting, which is 4/5, and then Ray missing. The probability is 1/4. If I put this in my calculator, I've got 7/20. Ta-da! There I've got my answer. 6 marks in the bag. Guys, this stuff is so simple. But it's very easy to miss a lot of things in this sum. So I'll encourage you, whenever they've got two events happening, one after the other or next to each other, I encourage you, think about tree diagrams and do not forget about the complement rule. It might feel like, oh, but so I don't have enough info. but with the complement rule, you will rule. The second question that I'm going to pose to you today is about mutual exclusivity and independence. So if I look at mutual exclusivity and independence specifically, I thought about getting this question from an old exam. Given that the probability of A is 0.45, the probability of B happening is Y, and the probability of A or B happening is 0.74. Determine the values of Y if A and B are mutually exclusive. Well, let's first of all stop and just look at what was given to us. The probability of A or B was given to us. So, we need to think about a formula for the probability of A or B. But we have one. Do we not? We've got one which tells us it's a probability of A plus the probability of B minus the probability of A and B happening. So, by subbing in the values that I've got 0.74 equal to 0.45 plus the probability of B. But now I'm sitting with mutual exclusivity, which means the probability of A and B happening is 0. So I'm going to substitute that into my formula. So now I've just got to solve the probability of B, which is Y, and that is 0.29. This is as simple as this. I'm going to add a little bit of a tail to this specific question. And I'm going to ask you this. Determine Y if A and B are now independent instead of mutually exclusive. So when I look at independence, it takes on a bit of a different story because independence tells me that the probability of A and B is the probability of A times by the probability of B. So if I look at this specific probability and I'm going to substitute this again into the formula, then the probability of A plus the probability of B, and the formula now tells me that I'm subbing in still, I've got an issue. What about that probability of A and B at the back? That probability of A and B at the back is now actually the probability of A times by the probability of B. Why? Because of independence. What you guys all long for. Is it not, ladies and gents, independence? So I'm going to solve by taking over the 0.45 and subbing in the 0.45 into the probability of A and the Y into the probability of B. Now I've got a basic algebra sum to solve. Now 1y minus 0.45y is 0.55y. And if I want to determine y, just divide by 0.55. And my final answer for y is then 0.53. And there you've got your value for y, or the probability of B. So when we talk about mutual exclusivity, or when we talk about independence, I encourage you, go back and get those formulas. Get those values that you need from your theory. If you haven't watched the theory video, please go and watch it, because it's going to help you a lot in the future. Ladies and gents, I encourage you, tune in to our next videos. The next videos is where we're going to tackle fundamental counting principles and how we look at them. This is Mr. VG signing out. Have a wonderful, wonderful, amazing rest of your day. Remember, you are awesome. Keep well. Cheers.